Hello and welcome to another Palmer Trinity CAD video. This video we're going to focus on the Loft tool and the Sweep tool. They're very similar in how they're used. Their goals are to make 3D objects from sketches, very similar to what we've done, but they allow us the flexibility of one transitioning between two different sketches. That's what Loft does for us. And moving a sketch along a path, which is another really powerful technique, so we can make exotic shapes. So far what we've seen is extrusions, but the extrusions are usually only for going straight up, and that's kind of a limitation. So perpendicular from the sketch, we go straight up, and that's kind of okay, but we can't do really much with that. If we want to curve, or maybe want to make a pipe that bends, or a handle, then that's not so easy to do with just a plain extrusion. So Loft and Sweep are going to be powerful tools that we're going to use. So for the Loft, first it takes two steps. One is to have an initial sketch, the bottom of the loft or the beginning of the loft. Second requires us to make another sketch that is parallel but at some other distance away. So in a plane that's parallel, so if we were to draw on this bottom flat plane, that would be one sketch. But then we need another one up in the air that is still parallel but higher up, a distance away. And so in order to do that, we must have a plane available to draw on. And so we're going to use our construct menu this time to make that happen. So let's first, and we're going to do something very simple. We're going to make a circle in our original drawing. And then our second drawing is going to be a square, and the goal is going to be to kind of stretch and make a 3D object by blending through both sketches until we have a new kind of exotic result. So let's go ahead and do that. So let's make a new sketch. I'll create a new sketch menu. I'm going to choose the XZ. And again, it's not important, but as long as you pick whatever plane you're going to do, as long as you're parallel when you make it, it's acceptable. So XZ is the one I'm going to choose. So there it is. I'm going to make a circle. So here's a circle button in my create menu. I'm going to coincident with the center. I'll drag it big. I'll go ahead and just put it at 100 millimeters. And there it is. And it is already perfectly constrained. I don't have to do any other work. And that's good enough for this first sketch. And there it is. So now I want to make a second sketch, but I can't draw on the same plane because then they would be on top of each other and that wouldn't be helpful. So the goal is going to be to make a new plane that is parallel to XZ but offset by some amount. And so in our design taskbar, we have the construct menu near the middle. And in the construction, we have a bunch of options. We can make our own planes. We can make our own axes. We can make our own vertices. And so this first option, offset plane, is very helpful. So we can make planes offset from other planes. We can make planes that are offset from flat faces or from sketches. And so in this case, we have two options, the sketch that we just made and the plane that it was drawn on. So either one of those is going to be acceptable. So let's click offset plane. And notice what happens is it gives us the origin, all those things. And I also have the sketch option, but I'm going to pick the same XZ. So make sure it's gray. I know it's kind of fighting with the sketch. Actually, I'm going to hide the sketch temporarily. And I'm saying I want to use this as a basis and then offset some amount. So I'm going to choose the XZ plane. And notice it gives me an error and says, well, how far do you want to go up? So this number is not arbitrary. This is how long we want our loft to be. So our circle is 100 millimeters. Let's say that our loft goes up 75 millimeters. And so you can see that it's actually made another of these yellow planes, which are just kind of references of the planes, not actual things, that is 75 millimeters up. So I click OK. From the top point of view, you wouldn't really notice that it's there, right? It looks like it's just flat. But we should hopefully see from a side point of view that it is up here, and it's hard to see it, but that's the idea, that it is kind of above and parallel with the XZ plane. So I'm going to go to the home view, and that's probably the easiest one to set. Right? And we can see that they're both there. There's the origin on the XZ, and then up here is the plane that we just made. And so notice that we also have a new folder in our browser, and it's called the construction folder. And that has the objects that we created, in this case, a plane. And there it is. It's called plane 1. I can rename it if I like, but it's unnecessary. I'm just going to refer to it just briefly. So now let's make a new sketch. So I'm going to do create sketch. But now, not only do I have the original options, but I have this offset plane. And I'm going to click it. And we can see that from the top point of view, it looks like as if I'm drawing on the same plane as the original sketch because we can see the original sketch, but that's not really true. If I rotate my camera, we can see how this is different. The grid that represents the area that we're drawing on is now floating above the circle where the original sketch was, which is where the origin was. So it works out nicely for us. I'm going to go back to that top view because it is helpful to see it from the top. And that circle is not really necessary. It's not going to really have an impact on it. I could hide it temporarily just because it doesn't really matter to me. I'm going to use the create menu to make a rectangle, but this time I'm not going to choose a 2-point rectangle. I'm going to use a center rectangle, mainly because that way I can origin it to the center without having to do a lot of extra work. So it's convenient to do this. So center rectangle. My center will be the origin. And now this is the only problem though. The origin is not really available because it's not part of the offset plane. So maybe we would have to project the origin onto that. So let's do that. So I'm going to hit escape to cancel what I was about to do. I'm going to go to the create menu. I'm going to go to project include. And I'm going to click project. And I believe, oh, maybe not. Maybe we can't do this. Is it going to be possible? I don't think so. So maybe we can't do that. What else can we do? I guess we can, let me think for one moment. Perhaps we can do, actually, let's be smart and use the circle now to our advantage. Since this does exist, we can use its origin, which is in the origin. So now that I've had the circle back visible, let's go ahead and try what I was going to do. I'm going to say create rectangle, center rectangle, and now I can use this circle as the origin. There it is. So now, and then now what I'm going to do is, and notice what it does for us is it kind of uses construction lines to easily tell us how big it is. So I want it to be 150 by 150. So it is a square and it is centered. So it works out nicely. So the result of this, if I go ahead and finish my sketches, I have two separate sketches. I'll make them visible. And there they are. Here's the original on the origin plane, and here's the square that I made on the offset plane that is 75 millimeters up. And so this is great. So let's go ahead and make a loft from these two things. So a loft is, again, the kind of joining of two sketches into a 3D object, and the transition is kind of automatic for us. So I'm going to try this out. I'm going to go to the create menu, and we have this loft option. And look at the picture, it's very similar to what we're doing. Theirs is kind of upside down to ours, but essentially we pick two different planes or surfaces and it will draw or build a 3D object between the two. So here we go. It says the profiles. The first profile I want is the bottom one. There it is. And the second profile I want is the top one. And as soon as I do that, immediately we have this shape being made. And it may look strange, but you can see some like shadowing and glare because this is not a perfectly square transition. It's from a circular, smooth surface to a rectangular surface. So the blending of those things is automatic. There's some other options. We're not going to touch too many of these guide rails or center line, but what could be useful, one thing is we want a new body because we don't want to blend these two. I believe there's an option that lets us, no, we're not going to mess with any of those. Center doesn't really help us. Well, I guess we're fine with this. It's not really a problem. Never mind, we're not going to touch any of these. We're going to keep these the way they are. So there it is. And so the result is a nice smooth transition. You can see that it starts off round and it automatically, so it figures out this shape automatically. So if I made a more exotic shape, then the circle would have to adjust to it. Any two sketches can be lofted between each other. Now, that said, if the shapes are really odd, then maybe we have to be careful because the loft might warp and pinch and not look correct. But it is generally a useful tool to make these blend smoothly. So this is kind of like a funnel, but it's a square top with a circular endpoint funnel. And so another option I can have, let's hollow this out. It would be interesting to be able to cut it through, but now because this is an exotic shape, cutting it straight down in a square would mess up the bottom part because as we get closer to the round part, it's no longer square, right? It's kind of bulging round because of the circle. And so instead of doing a drawing on the top surface and extruding downward to make a cut, we'll use a tool called the shell tool. And it's the third button as well, but that shell tool says, look, well, whatever object you have, if it is solid, we can hollow it out and make it so that the walls are a certain thickness. So I'm going to click the shell tool. I'm going to choose the object. This is where I'm going to shell from, and then it gives you an arrow so I can just drag it so we can see, and it tells us how thick the walls are. I notice the internal walls are also curved a bit because they are also following the contours of this shape. It's not a perfect rectangle. If you notice, actually, the thicker it becomes, the more rounded the walls are, mainly because that's where the rounding is, right? And so notice this number 10 millimeters. Let's do something like 5 millimeters. So that's a pretty thin wall, and we can see from the inside and outside we're still maintaining that nice curve. The cut is an intelligent cut, and it's a very useful tool. So I'm going to click OK. And there it is. And then now what I could do is I can cut a hole in the bottom. So now let's pick this bottom surface, and let's go ahead and make a new sketch. And I'll do a circle. So I'm going to choose a circle from my menu. And now I know that this circle is 100 millimeters, so let's do something like, let's dimension it. I put it there, let's dimension it to 90. And then now let's cut this out. I'm going to finish the sketch, and there it is. I'm going to choose the drawing I just made. And again, it's not the whole bottom, because you can see that I left the gap because it wasn't 100. And let's extrude it. So I can hit the extrusion tool, and let's bring it down and cut it through. And again, remember, when we cut through things, we don't necessarily want to use the distance. We can say all in our extent, and that way it cuts off exactly how much it needs. And there it is. So I click all, and there it is. We have like a part that it kind of is, it's a very funnel-like part. Obviously, if we made it longer and thinner, it would be even better funnel. But the idea is that it is kind of like a bin that things catch into and then fall down through, and we've made it kind of pretty shape. And it's exotic in the terms that it's not perfectly square. That roundedness is blended smoothly, and the curves are made for us, which is very convenient. So this is the Loft tool. This is a pretty useful tool to have. So the next tool we're going to use is the Sweep tool, which is very similar, but the big difference is that instead of being from one drawing to another, we're going to kind of drag a sketch along a line, a path, right, in 3D or potentially in 3D, and the result is a 3D object. And this is a pretty powerful thing. So I'm going to make a new design just so we have one. I'm not going to mess with this one anymore. There we are. A sweep takes two things: a sketch to sweep along a path and a path. So I typically draw the path first, so I have a sense of what kind of shape that I want. So I'm going to make a new sketch, and since I want mine to be standing up where ZX or XZ is the bottom, when I draw my path, I'm going to draw it on either the XY plane or the YZ plane. So either one of those is acceptable. So I'm going to probably do the XY just because I think that's easier. So I'm going to make a new sketch. I'm going to pick the XY, which is the green and yet the red side. And now here I'm going to make a path. We've done shape, we've done lines, we've done stuff like that. I don't want a perfectly sharp line, so instead I'm going to do something a little more exotic. I'm going to start off with a relatively straight line. So I'll start with the line tool, and I'll start it here, and I'll make it just go up to about 50 millimeters. And there it is. That's all I really wanted. And it is a vertical line. That's acceptable. And now what I want to do is attach this. I want to make like an exotic curve. And so I could use an arc, which is a circular thing around an origin, or if I want to have more a curve that I don't necessarily have the measurements for, but looks good and can be really warped and played with, a good choice is what's called a spline, which is this fourth button, a fit point spline, or we can go to the spline section. And there are two of them, but fit point is the one I'm going to use. And so I'm going to connect my spline, and what a spline is basically a complex polynomial function that generates a line that passes through all the points on it. So we'll start off by connecting them, and there it is, the little green square. I'm going to click it. It looks like a straight line now, but once I put my second point and I have a third point, the line will curve to pass through all the points. So I'm going to go ahead and put my next point right here, and notice the preview shows me what that line is going to look like. So I'm going to go like this. I'm not going to make it too curved because then it's going to have problems in the future. So like that, and I'll come back up here and do one last one. I'll zoom out a little bit more so we can have a sense of where the curve is. And I'll stop right there, and then I'll click the green check mark to stop it. And so there it is. I'm going to click away for a moment and hit escape to get rid of the tool. And there's the curve. And notice the line is blue because it's not constrained, because it's a curved line that's super exotic. It's hard to do that. So we're not going to really constrain it. What we do have is the ability to select any of the points that we created, and as we do that, we have these anchor bars that allow us to control the warp of the line. If we click on one of the green dots on the anchor, we can change the curvature of the line. If we make the green bars longer, the anchors longer, then the line becomes more loose and bloated. And if you bring the lines closer together, the green line's tighter, smaller, the line becomes sharper and more straight. So I'm going to play with this endpoint just to show you. I'm going to click on this bar and drag it up, and we'll notice as I do this, oops, let me try one more time. As I do this, the line curves, because essentially what's happening is the line is trying to slowly come to a tangent point at that white dot. And so it's tangent to the anchor line that I have. So notice the curve has to go around, and then it comes back and is tangent with the anchor that we created. So I can play with these anchors as I see fit. and make them more or less curve. If I make the anchor smaller, notice how the curve tightens and slowly becomes straight. We have to be careful. There are limits to what we can do, and we don't want to over warp things, because if it's too sharp of a turn, our sweep will not work effectively. So we have to kind of be careful. But with this, we have a lot of control of what our curve looks like. And every single point that we made can be done. And of course, we can also click on the point and move it freely. So this is a nice thing to be able to do. Right? But I'll point out, for this example, we do not want to make it too steep of a curve, because if we do, then the sweep may not work effectively. So I'm happy with this drawing. Again, this is a free form. We're not being very strict about how to make this happen. So I'm going to go ahead and click Finish Sketch. So there's my path. If I look at it from the side point of view, this is what my path looks like. It's kind of like almost like a question mark. And that's a 2D line. Even though it is a 2D line, it is in 3D space, so it sticks out, and we can see that it is sticking out and going along two dimensions in this graph, in this chart. So we're going to go now to the next step, which is making a sketch that is perpendicular to one of the endpoints, and then we're going to be able to sweep it across that path. I'm going to choose the bottom mainly because I was smart enough to make an easy straight line to be perpendicular to, and of course the origin is there, which is convenient. I could also make a sketch perpendicular to this top point, but that would probably be more challenging. So I'm going to make a new sketch on that bottom face. So I'm going to click on Create Sketch. Oops, I have to kind of undo that because I had something selected, so I did not mean to do that. So here we go. I'm going to click away so there's nothing selected. I'm going to click on New Sketch, and I'm going to pick the XZ plane. And of course, this line looks very thin and invisible because we're looking at a top-down view. So let's go. I'm going to use a circle. We could use any shape. Any closed sketch would work, but I'm going to use a circle because that tends to be easier to visualize and quickly produce. So let's make a circle. Let's make it just coincident with the origin, and let's not make it too thick, because if it is, it might overlap on itself, and we don't want that. So I'm going to go ahead and put 10 millimeters in thickness. So it's a pretty thin circle. So the result is we have a circle at the very bottom of our curve, and we have the actual circle. So now here's the last step. I'm going to finish my sketch. There we are. We can see both the circle and the curve path. We're going to use the Sweep tool. So I'm going to go to the Create menu. The Sweep tool is right here, and if you look at the picture, they show basically what we just did. They have a picture, a profile or sketch at the end of one of the paths, and then they can drag it along and make a 3D object. So we're going to do the same thing. So I'm going to click Sweep. The first option we're not going to touch is single path. We're only using one line, so this is the safest bet. The profile is the thing you want to drag along the line. In our case, it is going to be this circle. So there it is. The path is the line you want to follow. So I'm going to follow this giant line. This is one object. And notice how it highlights the whole thing blue if I hover over it, including the straight part. I click it, immediately it says, okay, well, there it is, a 3D pipe that goes along that path. And so now I've made a very advanced curve, so you can imagine if you were working, for example, if you're a designer for a company that makes refrigerators, one of the ways that refrigerators works is they have a set of coils or copper pipes that are curved in and out, and this is what allows liquids, the cooling liquid of Freon to pass through and release the heat from the machine, which causes the temperature to drop. Right. So so if you need to make a particular shape or looping of lines, this is a good way to do it. And the gray bar could be the actual pipe, and we could always make it copper or whatever it happens to be. And so this path is really useful, and we're allowed to say how much of the path we actually want to use. Right now, the distance is 1.0. It means 100%. But I can grab the arrow or change the number and say, you know what, don't use all of it, only use a portion of it. So you can notice that I can say, well, I only want to use 42.5%, right? 0.425 is 42.5%, or 75%, or whatever it might be. So I can play around with that and use it. Twist angle is convenient, mainly because it allows you to, as the shape goes on, it says how many degrees should it rotate from beginning to end. But because our shape was a circle, if you twist a circle, you end up with a circle, and so you won't notice it. But if we had some kind of polygon or rectangle, we might see a twist or curve along the transition, which could make the shape very different. The last option that's probably useful to us, whether we use a circle or not, is called the orientation. By default, the behavior is what's called perpendicular. It means if you were to take a slice or look at the line at any point on the path, the shape or the sketch that was started is always perpendicular to that point. So at the bottom, it's perpendicular to the bottom, so that's why it's flat. Over here, it's at an angle because it is perpendicular to the line at that point. So if you were to draw a straight line that's tangent, that would be where it would roughly be perpendicular, and that's the thing. So at every point, the sketch is perpendicular to the path that it's on. If I change this to parallel, we get a very different type of sketch, for better or for worse. And this might be what we want. And so notice it looks the same about here, but at this point, it starts to get thin, like it's a squished pipe. And the reason is, what it's saying is that for any point on the path, the sketch must be parallel to the original, which means that it has to be flat on the XZ. So all the paths, no matter what. So if I look up here, you will notice that the top is kind of tapered because it is perpendicular to the bottom, right? Not perpendicular, parallel to the bottom. And that's okay, but then you end up with like a pinch over here. So notice how the pipe is a lot thinner there, and the pipe is a lot thinner here, because as it curves sideways in a direction that's not directly perpendicular to it, it ends up being flattened. So typically we probably want perpendicular as our option, and it keeps the shape basically along the path. So this is a great way to make handlebars or curves or pipes or things that are not standard shapes, that are not simple curves. This is a very powerful technique. So I'm going to stop the video here. These are two very great tools to use to enhance our creation of 3D objects. I'm going to click OK, and I'll see you in the next video.